Hi everyone, it's Alyssa and welcome to You Can Learn Math. So today we're going to be talking more about exponents. This is part 3 in the series. There are links in the description below to parts 1 and 2. And in those we discussed things like multiplying numbers that have the same base and different exponents, what we do there. We also talked about if they have the same exponents but different bases, talked about negative exponents, and we also talked about division. So if you are interested in any of those topics, the links are in the description below. Again, that's parts 1 and 2 on exponents. So this one, part 3, we're going to be talking about fractional exponents, by which I mean something like this. 5 to the power of a half. So we know 5 squared is 5 times 5. Well, what is to the power of a half? That doesn't mean a half times 5. That can't be it, right? No, that's not it. What this actually means, if you kind of look at it this way, half is the inverse of squared. It's inverting it, like we have multiplication, division. Those are inverses of each other. Addition, subtraction. So this is a way to help you remember this. Think of like a half being an inverse of 2. Well, what's the inverse of squaring something? It's square rooting something. So that's what this is. 5 to the power of 1/2 is square root of 5. Okay? Now this still obeys all of the rules we talked about in the previous parts. For example, when we said like 5 squared times 5 cubed, we add those together. 2 plus 3 is 5. It still works here. And we can see this really clearly just by taking that 5 to the power of 1/2. 5 to the power of 1/2 times 5 to the power of 1/2. 1/2 plus 1/2 is 1. 5 to the power of 1, or just 5. Well, we've said that 5 to the power of 1/2 is the square root of 5, and the square root of 5 times the square root of 5 is just 5. And if that can be a little hard to see how the square root of 5 times the square root of 5 is 5, let's do some numbers that are perfect squares. So let's say 16 to the power of 1/2 times 16 to the power of 1/2. 1/2 plus 1/2 is 1. 16 to the power of 1, which is just 16. Okay, now let's say square root of 16 times square root of 16. Well, this I actually know the square root of 16 is 4. Square root of 16 is 4. 4 times 4 equals 16. So we have a match. It is the same answer. Okay. Well, that's, 1/2. What if it is something to the power of 1/3? Well, here's the thing. When we say square root, we don't have to write it. If we're saying like square root of 16, but it's understood there's a 2 right there. We don't usually write it because we know that just means square root. Means what times itself 2 times equals 16 is what this is asking. So for all of our other roots, if we're saying what number times itself 3 times would equal 16, we put a little 3 there. Now it's a cube root. And that's what this 16 to the power of 1/3 is. Again, to the power of 1/2 was a square root, which technically does have a little 2 there, but we just don't write it because we all know that's what it means. But for these, we would write it, and it's the cube root of 16. Okay? And with that in mind, let's take a wild guess as to what this would be. I bet you'll never guess in a million billion years. Oh my goodness, you guessed. Yes, it is the fourth root of 16. It is what times itself 4 times equals 16 is what that's asking. And this just keeps progressing. We could have the 5th root, the 6th root, the 7th root. We could go on forever if we wanted to. Why would we want to, though? We don't want to. We want to do something else. And what we want to do is ask, what if it's not a simple 1/2, 1/3? What if it's this? Well, let's think back to what we were doing before. So if I had this right here. Oh, sorry, not this. I'm getting ahead of myself. I'm doing something else. Okay, so 16 to the power of 1/3 times 16 to the power of 1/3. We would add those together and we would get 16 to the power of 2/3, right? Okay, so this has to be equal to 16 to the power of 1/3 times 16 to the power of 1/3. Well, let's say, what is 16 to the power of 1/3? We said it is the cube root of 16. So say, okay, cube root of 16 times the cube root of 16. Or, since anything times itself is a square, we could call this the cube root of 16 squared. Okay, so, sorry, my cat is jumping up in my lap and on my laptop. Go over there, baby. I love you, but you need to sit over there right now. Thank you, sweetie. Okay, so we have the cube root of 16 squared. And look, we have the number 3 and we have the number 2. Do those look familiar? Why, yes, they do. Let's try another one. What if I had, say, 6 to the power of 3/4? Well, 6 to the power of 1/4 times 6 to the power of 1/4 times 6 to the power of 1/4. We would add those exponents, and it would be 6 to the power of 3/4. 6 to the power of 1/4 is a 4th root of 6 times the 4th root of 6 times the 4th root of 6. So this would be the 4th root of 6 cubed. Looky there. 3, 4. 3, 4. So there is our pattern. So let's put it in a very straightforward sort of rule. If you want to see this written, you might see it sometimes written like this. X to the power of m over n is equal to the nth root of x to the power of m. When things are presented with variables, it can look very confusing and can be a bit daunting. But as you see, that's exactly what we just did. We proved that 16 to the power of 3/4 is equal to the 4th root of 16 to the power of 3. That's it. That's all we did, step by step. So are there times when we can simplify this? Well, actually, this one right here we can. The 4th root of 16, we're asking what times what times what times what equals 16? Well, it's actually 2 times 2 times 2 times 2 equals 16. So the 4th root of 16 is 2. If I cube that, that's 8. So 16 to the power of 3/4 is 8. And this here really illustrates amply why we don't want to get thinking that this means 3/4 of 16. Not even close, because you see 8 is a half of 16. So we really don't want to look at 3/4 and think that means what fractions normally mean. It means this very specific thing. We're taking this root and putting it to this power. That's what we did. This root to this power. Okay, so that is fractional exponents, and these do behave in every way just like the other ones we've been doing. So the same rules apply even though it's a fraction. I know I showed you where you add them. So like 4 to the power of a half times 4 to the power of a half. You add those together to be 4 to the power of 1. The same rules that we've discussed about division and such, they just doesn't want to get off the screen. They still work. So if I had 4 to the power of 3/4 divided by 4 to the power of a fourth, I would subtract those exponents. 3/4 minus 1/4, I can't talk, is 1/2. 4 to the power of 1/2. Same process. You subtract, we're adding, same kind of thing. Additionally, if we had a power to a power, and it was 4 to the power of 1/2 to the power of 1/3, it's the same rule. We multiply those when it's power to a power. 1/2 times 1/3 is 1/6. Same rule. Okay. So all these things, it still obeys the same rules, same things. And actually, like, well, let's back up a little bit. Come on. Undo. There we go. All right, just undo that first erasure. Yeah, just as a little side note, if you want to see how this works, you could say it's 4, it's the 4th root of 4 to the power of 3. So it's the 4th root of 4 times the 4th root of 4 times the 4th root of 4. And it's being divided by the 4th root of 4. Okay? So, as we know, when we have things being multiplied together and it's in a division problem, then we can start crossing out top and bottom, things that match. So that matches that, and we are left with the 4th root of 4 times the 4th root of 4. And if you want to get a little technical, this is a little bit of bonus math here. If I have the 4th root of 4 times, I'm going to get 4, right? Because that's what it means. This is representing a number that when multiplied by itself 4 times, it's going to equal 4. So I could split this up and say the 4th root of 4 times the 4th root of 4 times the 4th root of 4 times the 4th root of 4 equals 4. That means each of these represents the square root of 4. It would have to be. Anytime we have matching pairs, if we factor something or we have roots and we have identical sets of matching pairs and it's 2, then each of those matching sets is a square root of that number. So square root of 4 times square root of 4 equals 4. So we've shown here that the 4th root of 4 times the 4th root of 4 is the square root of 4. So this is equal to the square root of 4. And what's another way that we said to represent the square root of 4? 4 to the power of 1/2. So that's a little bonus aside to actually show you sort of the nuts and bolts of what's happening. And just to kind of show you a little proof that yes, it still works. If we have 4 to the power of 3/4 divided by 4 to the power of 1/4, we can still just subtract. All right, so that's some broad details and also some specific details all about exponents with fractions. That's the end of part 3. In part 4, we're going to be looking at a variety of things, some different examples with negatives in the exponents, negatives in the base, 0 exponents, 1 exponent, things like that. Just some practice problems to just show you all of these in action. And if some people have questions about things with negatives and negative exponents and dividing by negatives and what have you, and just go through a couple of examples. That'll be in part 4. I hope you enjoyed this, hope it was helpful, and I hope you have a great day. Till next time. Oh, and of course, I do forget to say this. Please do like and subscribe if you enjoyed this video, if it was helpful in any way. It's really helpful to us too. All right, that's it. Have a good day. Bye.